Welcome back to Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to my channel for future videos and notifications. In this video, we're going to discuss the Super-Pythagorean theorem. This is something that's useful in some types of geometry problems, and most people probably never saw this going through high school math and even into college. I know I didn't. I actually first ran into it when studying for the GRE, and actually it's something that can come up on the GRE, and if you know how to do it, it's not hard at all, and it can get you some free points on something like that. So the Super-Pythagorean theorem is useful in a problem like this. Find the length of the diagonal, which we'll call d, in the rectangular prism shown to the left, assuming x, y, and z are 5 centimeters, 7 centimeters, and 9 centimeters respectively. Okay. Now, here's our rectangular prism. So x is just one of the side lengths, y is another side length, and z is the third side length. So just x, y, and z. Okay. In some sources, they'll call them a, b, and c. It doesn't matter. They're the three side lengths. I've also labeled each of the 4 vertices on each of the squares that make up this prism. So the bottom square right here and the top. So on the top, we have vertices 1, 2, 3, and 4. And on the bottom, we have vertices 1, 2, 3, and 4. And this line that's going from top vertex 4 to bottom vertex 2, this is the diagonal. Okay, it goes right through basically the center of the prism. Okay. And actually, it wouldn't matter if it's this diagonal. We could also have a diagonal from bottom vertex 1 to top vertex 3. It could be bottom vertex 3 to top vertex 1. It could even be bottom vertex 4 to top vertex 2. Those are all diagonals, and they're all the same in a true rectangular prism. Okay, so it doesn't matter. So this length right here of this diagonal is d. The formula we're going to use is very similar to the normal Pythagorean theorem. So if you take each of these lengths of the sides and add their squares, so x squared plus y squared plus z squared, that actually has to equal the square of the diagonal length, d squared. And so if your problem simply says find the length of the diagonal, well, then you're just going to take the square root of both sides. And so when you square root d squared, that's just d. And then the length of d is equal to the square root of the sum of x squared plus y squared plus z squared. Now in this problem, we know x, y, and z. They're 5, 7, and 9 centimeters respectively. So I would start out with a problem like x squared, so that's 5 squared, plus y squared would be 7 squared, plus z squared would be 9 squared, and then that equals d squared. I could even go ahead and calculate these exponents. 5 squared is 25, 7 squared is 49, 9 squared is 81. Those add to be 155, and so 155 is equal to d squared. Now to get d, I just simply take the square root, and so d is equal to the square root of 155. And if you had a calculator to approximate this square root, you'd find that d is approximately 12.4 centimeters. And so the Super-Pythagorean theorem is useful for when you have a diagonal in a rectangular prism and you're asked to calculate the length of that diagonal. Now technically you could break this up into 2 separate trigonometry problems where you would have to use the Pythagorean theorem in both cases. However, this formula comes from 2 separate Pythagorean theorem problems, and all you have to use is this. Don't do any derivations that are complicated. No, just do this formula, and it will allow you to calculate the length of the diagonal. In addition, if you knew the diagonal but didn't know the length of another side, you could also calculate those. Okay? Please make sure to like this video and subscribe to my channel for future videos and notifications. Thank you.